Hello everyone, welcome back to our soil mechanics video lecture series. In the previous video, we have discussed about the various types of soil water and how water behaves within the soil's pores. In today's video, we will go to a step further and study closely related and highly important concepts of soil mechanics, that is capillarity and soil suction. This phenomena explains how and why water moves upward or remains held in soils even above the water table, which is something every civil engineer must understand for foundation design, slope stability, and seepage analysis. So, this is the pictorial representation of capillary rise in soil, where the water rises above the capillary tube up to a certain height h. So, this phenomenon of rise of water is defined as capillarity. So, before we begin, let's quickly recap what we have learned in previous class. Soil contains voids filled with water or air. The movement and retention of this water are controlled by surface tension and adhesive forces between the soil particles and water molecules. These same forces are the reason behind capillary action and soil suction. So that is the most important aspect to be considered with regards to soil water. So let's dive into the concept of capillarity. Capillarity is the phenomenon by which the water rises in small pores or tubes against gravity due to surface tension. In soil, the tiny voids between the particles acts like millions of capillary tubes. The finer the soil, the smaller the pores and higher the capillary rise. So in case of clay soil, it shows a much higher capillary rise when compared with sand. So the capillary rise can be calculated with the help of expression which is suggested by Terzaghi and Pick in 1967, where Hc is equal to C divided by E into D10, where E is the void ratio of the soil, that is the ratio between the volume of voids to the volume of solids present in the soil, where D10 is the effective grain size of the soil in centimeters, and C is an empirical constant which have the value of range between 0.1 to 0.5 centimeter square, which is known as Darcy's constant. The application of capillary rise are it can be witnessed in the form of movement of water inside the roots and other parts of plants, and also it is witnessed in cotton clothing which has pores which absorbs the water. So this it also spreads in the lubrication of oil. So let us have an activity, that is a quick assessment. The students, can you explain what meniscus is observed in soil capillarity, that is upper or lower meniscus, and why so? And can you explain what is soil section? And next question is, what idea you have about surface tension of soils? So take a few minutes in order to answer these assessments. Okay. So let's move to the topic. I'm also here to further discuss about capillary zone and water table. So what do you mean by capillary zone? Capillary zone is the region above the water table. So the zone of water above the water table is defined as capillary zone, where the soil pores are saturated due to capillary action. So the top of zone marks the limit of capillary saturation, and the region above it gradually becomes unsaturated. This is very important in foundation engineering because if the foundation is within this zone, moisture variations can cause huge expansion, shrinkage or dampness. So there are also various several factors which affects the capillary rise of soil. First one is pore size. Next is type of soil, whether it is fine grained or coarse grained, and the temperature of the soil. If the higher the temperature, it lowers the surface tension. Next is degree of saturation, in which the partially saturated soil have discontinuous water films, which reduces the capillary rise. So that's it about today's video. We have learned about the capillary rise which is present inside the soil water and its significance in geotechnical engineering aspect. Thank you for listening to this video. Have a good day.